Hi everybody, welcome back to our video. We are dealing with the Kirchhoff's laws. We have been seeing about the Kirchhoff's current law and the Kirchhoff's voltage law. Now in this video, we are going to discuss about the next type of application, what we are going to do in Kirchhoff's voltage law. So what do we deal with the Kirchhoff's voltage law? So we are going to see what is this mesh analysis. So based on the Kirchhoff's voltage law discussed in the last, so we are going to see what is this mesh analysis. So mesh analysis is nothing but analysis using KVL to solve for the current around each closed path in the network and hence to determine the current through and the voltage across any part of the network. So the mesh analysis procedure is about the three-step process. Step 1, assign a distinct current to each closed loop of the network. Step 2, apply KVL around each closed loop of the network. Step 3, solve the resulting simultaneous linear equation for loop currents. So based on these three steps of example, so we will deal with a problem. So an exercise problem is being given over here. What is the problem? Find the current flow through each resistor using mesh analysis for the circuit given below. Here you have two voltage sources of 10 volt and 20 volt connected through three resistances R1, R2 and R3 of 10 ohms, 20 ohms and 40 ohms respectively. So here we are going to solve with the help of the mesh analysis. So what is the mesh analysis? Mesh analysis is otherwise also called as the loop analysis. So what are the three steps involved in mesh analysis? Assign a distinct current to each closed loop of the network. Apply KVL around each closed loop of the network. Solve the resulting simultaneous linear equation for the loop currents. So based on this, taking this problem into account, from the positive to negative, we are selecting the loop 1. From the positive to negative of the second loop, we are going to select the loop V2. The sum of the incoming currents at the junction point and sum of the outgoing current is taken and the LO. So this is the step 1. What is the step 2? So based on step 1, we are going to form two equations. So based on the current loop, I1R1 plus I1R3 plus I2R3 is equal to V1. So we have the values of R. So 10I1 plus 40I1 plus 40I2 equal to 10. Or this equation can be written as 50I1 plus 40I2 is equal to 10. This will be the first equation. So what is the loop 2? I2 into R2 plus I2 into R3 plus I1 into R3 is equal to V2. This is based on the Kirchhoff's voltage law. Applying Kirchhoff's voltage law for the second loop. So the expression for R can be rewritten as 20I2 plus 40I2 plus 40I1 is equal to 20. That is 40I1 plus 60I2 is equal to 20. That is the equation number 2. So we have got the two equations and two unknown methods. We can use any one of the following solving methods to solve the two equations and two unknowns to find out the value of our current I1 and I2. So here I am going to use the matrix form. So 50I1 plus 40I2 is equal to 10. 40I1 plus 60I2 is equal to 20. The matrix form becomes 50, 40, 40, 60. I1, I2 is equal to 10, 20. Find out the value of delta. So delta is equal to 50, 40, 40, 60. 50 into 60, 3000 minus 40 into 40 is 1600 is equal to 1400. So delta I1 is equal to 10, 40, 20, 60. The 60 into 10, 600. 40 into 20, 800. So minus, so we are going to find out the determinant. So which is equal to minus 200. So delta I3 is equal to 50, 40, 10, 20. So in each case, we are going to replace in the delta I1, first column is replaced with the value of 10 and 20. In delta I2, the second column is replaced with the value of 10 and 20. To find out delta, we have the same matrix of 50, 40, 40, and 10. So finding out the for delta I2, 50, 10, 40, 20 is equal to 1000 minus 400. That is 10 into 40 is 1000 minus 50 into 20. So cross multiplying the diagonal elements. So diagonal elements minus the off diagonal elements. So 10,000 minus 400 is equal to 600. So we have three values of delta I1 plus delta I2. So what is I1? I1 is nothing but delta I1 divided by delta. That is minus 200 divided by 1400, which is equal to minus 0.143 amps. Similarly, I2 is equal to delta I2 divided by delta, which is equal to 600 divided by 1400, which is equal to 0.429 amps. So from the KCL, we get I3 is equal to I1 plus I2. So that is from Kirchhoff's current law. I3 is equal to is the sum of the currents I2, I1 plus I2. So I3 is equal to minus 0.143 amps plus 0.429 amps, which is equal to 0.286 amps. So from this, we get the three currents I1 minus 0.143 amps, I2 0.429 amps, and I3 0.286 amps. So this is what about the mesh analysis. Thank you.